These are the lesson 13.2 notes for day 2. We're looking at angles on the unit circle. Today we're going to talk about something called exact values. So we're going to identify some common angles on the unit circle. We're going to find some exact values on the unit circle, and we're going to give exact values of sine and cosine on the unit circle as well. First thing I want to start with is recalling different measurements that you have around the circle. And the first thing I would like to do is I'd like to label angles in intervals of 30 and 45 degrees in the counterclockwise direction. So you may recall that when you're measuring values around the unit circle, now the unit circle again is a circle with a radius of 1, is that when you measure angles in the counterclockwise direction, this is considered to be a positive direction. So counterclockwise is positive. On this circle, there's probably some angles that you remember. Obviously, halfway around the circle is 180 degrees. If you consider 0 to be our starting point. Halfway to 180 degrees is 90 degrees. This is definitely 90 degrees because you can see this 90-degree angle between 0 and 90. What that means is that if you split this original quarter of a circle into thirds, this would be 30 degrees. The next big interval here would be 60 degrees, and then 90. Halfway between 30 and 60, this is a 30-degree space here, so halfway between 30 and 60 is going to be a 15-degree space between 30 and here, which would be 45 degrees, and then another 15-degree space between 45 and 60. So basically, each bigger wedge is 30 degrees on this circle, each smaller wedge is 15 degrees. So obviously, from 90, this is a big 30-degree wedge, so 90 plus 30 is 120. 120 plus 15 is 135. 135 plus 15 is 150. And 150 plus 30, the other big wedge, is 180. What I'd like you to do is, around this circle, I'd like you to add 30 degrees for every big wedge, 15 degrees for every small wedge, and you should end up back at 360 here in just a minute. Pause the video and let's see what you get here in just a second. So you can see going around our circle, we have measurements like 210, 225, 240, 270, 300, 315, 330, and if you add 30 more, you get back to 360. A full circle is 360 degrees, so 0 and 360 degrees are coterminal angles. They're both located at the same location. If we're measuring angles in a clockwise direction, clockwise is going to still start at 0 degrees here on the far right side, but we're going to go this direction. The difference is when you're measuring angles in a clockwise direction, this is considered to be the negative direction. So if we go from 0 down to here, this is a 30-degree jump, but we write negative 30 degrees. And then this is a smaller 15-degree arc here, so if we take another 15 degrees, attach it to the 30, now we're at negative 45 degrees. If we include another 15 degrees, now we're at negative 60. And then we have this bigger jump right here, which is a 30-degree interval that takes us to negative 90. What I'd like you to do is pause the video and write in the rest of the angles that go around the unit circle this way, finishing up at negative 360 degrees. So continuing around the circle, our measurements we have are negative 120, negative 135, negative 150. Negative 180 degrees is located at the same location that positive 180 degrees was. So negative 180 and positive 180 are coterminal angles as well. Then we have negative 210 degrees, negative 225, negative 240, negative 270, negative 300, negative 315, negative 330, and we're back at negative 360. So again, both positive 360 and negative 360 are located at the same location, making them coterminal angles. Finding exact values on the unit circle. We're going to give exact values of coordinates on the unit circle at each 30 or 45 degree interval. Now, because this is the unit circle, a circle with a radius of 1, if you consider the center point here to be the origin, and this being our y-axis and this being our x-axis right here, you can consider that the value here, that I've just put a dot at, along the x-axis, has the coordinates 1, 0. And this should allow you to also find coordinates of all of these points that are located at intersections of an axis and the circle. So we have values like 0, 1 up here, negative 1, 0 here, and 0, 1 down here. So we'll start with that. the question becomes, well, what about some of these other points on the circle that are a little bit more difficult to find? Well, what I'm going to do is I'd like to mark the halfway points along these axes, the value at 0.5. So this is 1, this is our radius of our circle, but where's the halfway point? Well, here it's about here. This is kind of about negative half. Going up here, this is about half right here. Going down here, we got about half this way. And what you'll notice is if you move straight up from this point, there's actually an intersection on the circle. And if you go straight down from this point, there's also an intersection on the circle right here. Over here, if you move to the left half, if we go up, there's a point at 0.5 right here and a point that's at 0.5 here. Now, 0.5 is the same thing as the fraction 1/2. And if we're talking about an exact value, exact values typically are written as fractions. Exact values have no rounding and no decimal value. So 1/2 is considered to be an exact value. Usually we don't write 0.5, although it is a decimal that ends. Usually we write 0.5 as 1/2. So the x-coordinate of this point here is 1/2, comma something. And likewise, the x-coordinate of this point here is 1/2, comma something. And the x-coordinate on the left side here is at negative 1/2, comma something. And the y-coordinate is, well, we're trying to find that out. And over here, the x-coordinate of this point is left 1/2, and it's up something. Now, how far up is it? It appears to be up about, well, it's pretty large, almost at 0.9. It's actually 0.866. And this is not a repeating decimal. We'll call it 0.87 actually. 0.87, or this decimal value, is actually located at exactly the value square root of 3 over 2. In fact, if I type this on my calculator to verify it, you'll see that the square root of 3 divided by 2 is indeed 0.87, or 0.866025438. That's the y-coordinate of this value right here. Square root of 3 over 2. In fact, that's the y-coordinate for this point as well. It's up the same distance, square root of 3 over 2. And you can tell it's up the same distance because they're directly across from each other. These points are down that same distance. So this point on the bottom right corner is at negative root 3 over 2 for a y-coordinate. It's down square root of 3 over 2. And this point is directly across from this other one. So it's also has a y-coordinate of negative square root of 3 over 2. And what's kind of cool is all these points, if you connect them, you end up with a rectangle. And that basically ensures that the x-coordinates and y-coordinates are basically either the same or opposites of each other. Now, I'm going to change the color here to blue, and what you'll notice is that this other value that was up 1/2 also has points that are directly aligned vertically with 0.5. So we have points here and here. In fact, I could even connect, I can make a little rectangle going this way to get me to this point, and straight across over to this point. And we have another rectangle that's formed here. This point is over, it appears to be over 0.866. In fact, its x-coordinate right here is square root of 3 over 2, and it's up 1/2. That's the coordinates of this point right here that's at this kind of 30-degree mark. Directly across from it on the left side, we're going to the left 0.866, or left square root of 3 over 2. So we write negative square root of 3 over 2, comma, and it's up 1/2. The point directly below it is still left square root of 3 over 2, so we write negative root 3 over 2. But it's down 1/2. You can see it matches up with going down 1/2. So we write negative 1/2 as the y-coordinate. And this point here is over 0.866, or square root of 3 over 2. And it's down negative 1/2. So all the points that I've labeled with this different color here have either the root 3 over 2 or negative root 3 over 2 as the x-coordinates, and 1/2 or negative 1/2 as the y-coordinates. Changing my font one more time, we have one more value to find. It's these 45-degree angles. What you'll notice about this point is it appears to be over a little bit more than half, but not quite 0.87. In fact, the y-coordinate here, or the x-coordinate here, is equal to about 0.71. This is equal to, or approximately equal to, the square root of 2 over 2. And that's, in fact, exactly where this point is located at. It's located the same distance over as it is up. And it's located at 0.71, or root 2 over 2, comma, root 2 over 2. This 45-degree angle has the same x and y coordinates. So the point directly below it has an x-coordinate of also right 0.71, or root 2 over 2, but it's down, so its y-coordinate is going to be negative root 2 over 2. And then you can kind of form this little rectangle. In fact, this time it's a square. This point here is left 0.7, or negative root 2 over 2, and it's down 0.7, or negative root 2 over 2. And then the point directly above this lines up perfectly. It's also left negative 0.7, or root 2 over 2. This time it's up, so its y-coordinate will be positive. And you can see these points that make this square have the same x and y coordinates. If it's on the right side, the x-coordinate is positive. If it's on the left side, it's negative. For the y-coordinates, if it's above the y-axis, the y-coordinate is positive. If it's below, then it's negative. So what we're going to do finally here is give exact values of cosine and sine on the unit circle. Now, you may recall that to find x is equal to the cosine of theta and y is equal to the sine of theta. So in our first example, if we're looking at 30 degrees and I ask you to find the cosine of 30 degrees, this means what we're trying to give is cosine is x. We're trying to give the x-coordinate on the unit circle at 30 degrees. And if you look at where 30 degrees is at right here, that's this blue point. The 30-degree value here is root 3 over 2, comma 1/2. The x-coordinate is square root of 3 over 2, and that's what we're looking for. To verify this, you could use your calculator. If you type in cosine of 30 degrees, what you should get is 0.866. Remember, if you don't get this value, check the mode on your calculator and make sure the mode is set to degrees. Cosine of 30 is 0.866. It says give the exact value, so I don't want any decimals. Exact values mean I should have nice integer values in my fractions, which I do, square root of 3 over 2. And the square root of 3 over 2, in fact, is equal to 0.866. So I do have the right value. What you should be able to do is refer to angles based on degrees that we wrote on the front side of your worksheet. And then cosine just means use the x or y values that we've written in to our chart right here. Let's try one more example. Cosine of negative 30 degrees. Well, you may recall negative 30 degrees means we're measuring in a clockwise direction. That's this angle down here, kind of one space down. Again, we're looking for cosine, which is the x-coordinate down there, and the x-coordinate of that point is square root of 3 over 2 again. So that's the answer that you're going to write down. What I'd like you to do is pause the video and see if you can come up with the values for these other three values. So for cosine of 225 degrees is located down here in the bottom left corner. Cosine means we're looking for the x-coordinate at 225, which happens to be right here, negative root 2 over 2, so that's the value that we write down for that example. If we're working with a sine of 30, sine is the y-coordinate, so we want the y-coordinate at 30 degrees. Based on the unit circle, the y-coordinate is right here, that's this 1/2 value. Finally, sine of negative 135, to locate that, we go back to our unit circle. Negative 135 is located in the bottom left corner right here. The y-coordinate at that value is negative root 2 over 2, so that's your sine of negative 135 degrees, and that's how you find exact values on the unit circle.